Today we're going to present the practical work developed in the field for the application of supervised classification techniques in the intertidal zone. We are at Vilateral Rocky Shore, that is one of the study sites of the UAV project. As part of this project and in the scope of the UAV4SEA bilateral initiative, we're going to map the intertidal zone using drones equipped with RGB and multispectral sensors.
This drone carries two cameras. One of them is a standard color camera, RGB, so as our conventional cameras. It is a high resolution camera with 20 megapixels. It also carries a multispectral camera. It has 5 lenses, so it will capture 5 different images at the same time. Each image has an individual wavelength, so this is why we call it a multispectral camera. It will obtain images in the red, in the green, in the blue, the near infrared, and also an intermediate wavelength between the red and the near infrared, which we call red edge. So this camera will produce 5 different images, which actually cover exactly the same area, but we get different responses in different wavelengths. The RGB camera will be used mainly for a visual interpretation of the terrain, and also for the photogrammetric processing that we do that in order to extract a 3D model of the ground, which is needed to orthorectify the images. The multispectral camera has a lower spatial resolution, but it has a better spectral resolution, so we can identify exactly the wavelengths of the different images. For the multispectral camera, we also have here a radiation sensor, because the images that we are getting, they will capture the radiation that is being reflected from the ground, radiation that comes from the sun. So we need to know what radiation we are getting from the sun at that moment. So there is a sun radiation sensor that is needed to calibrate the images for the moment of the flight. For that purpose, the camera we need to use a panel that has a color that we know, so we will get an image of this panel to calibrate the radiation intensity that is being captured in that day. Preferably we should make all the images with the same illumination of the sun. If you get different, for example, clouds during the flight, it is not very good, so we should have a constant illumination of the sun. The cameras are not rigidly fixed on the drone. They have some flexibility. This is what we call a gimbal. The idea is that the drone is flying with cameras pointing vertically, but due to the tilt of the drone, images might be slightly displaced from the vertical. So the gimbal will compensate for that and will always keep the images rigorously vertical, so that we need for to build the mosaic of the images. All the drone is guided by GPS, so there is a GPS receiver on the drone that will automatically guide the drone for the pre-planned flight.
The first step to map the intertidal is to identify its main biological geological elements. This usually requires previous knowledge of the area acquired with field work to assess these elements. Therefore, at Vilateral Rocky Shore, we identified 4 main elements, which are mixed algae, which is a mixture of green, red and brown algae, usually on a bed of sublidia. And the other element is mussels and rock, which is dominated by mussels on rocks. The third element is rock, barnacles and limpets, which is basically a set of barnacles on rocks with some limpets. And the last one is sand, which usually can be moved around by the influence of the sea. In order to apply the supervised classification techniques, it is essential to define training and validation areas. These training areas are usually geo-referenced, are essential for the classification itself, while the validation areas are used for the assessment of the accuracy of the classification. Next, we're going to see how to define these training and validation areas in the field. To ensure that we are inside the area of the flight of the drone, the region of interest, we're going to use a GPS tablet that will give us the current position on the field. The definition of the training areas and validation areas in the field can be performed in two methods. The first one requires a quadrant frame of 50 by 50 centimeters that we place upon the area we are interested in. Then we label that area and collect its coordinates. Afterwards, we leave the quadrant on the shore until the flight is performed, so that when we are doing the photo interpretation, we can identify the quadrants and define the training areas drawing polygons. The second method also requires that frame, but instead of leaving the quadrant on the shore, we just use it to mark the area that will then collect the center of its coordinates. But then in QGIS, by buffer procedures, we're going to draw circles of 25 centimeters. In this way, we avoid having to place the quadrants and later collect them from the shore.
This is the drone controller. It has a tablet where we run software for the flight planning. In this flight planning software we define the area that we want to cover, and for that then there is a set of waypoints that are established, which will be transmitted to the drone, and the drone will be guided to those points with the GPS in order to capture the images in the exact places that we need for our mission. All the drone flight is guided by GPS. It is a navigation GPS, so GPS receiver, which has an accuracy of a few meters, which is enough to do the mission that we want. The drone we will acquire a set of images, probably a few hundred, that cover our study area. We need to mosaic them, to join them all in a single image, and that needs to be georeferenced with a very good accuracy, because our images will have a resolution of 1 or 2 centimeters, and we need to know its georeferencing with a very good accuracy so that we can overlay images from different times. In order to have a precise georeferencing, before the drone is started, we need to place some artificial marks on the ground, and we use a precision GPS receiver to collect precise coordinates, latitude, longitude and altitude of those points. So this is a precision GPS receiver that will provide those coordinates. These will then be identified later on the post-processing of the images in order to provide the precise georeferencing of the images. On the sand we use artificial signals like this. On the rock, over the rocks, we paint some signals with a biodegradable spray, so that we have precise signals that we collect also on the rocks.
After all the procedures in the field, the drone takes off and the data are collected upon its return. These data are then processed in a GIS software in order to produce the supervised classification maps